Welcome to my TED Talk. Okay, so we have a few agendas, right? So I'm going to give a quick review on the Datadog ADR, why we choose Datadog as our monitoring tool, its benefits and drawbacks. I realized that we never really properly introduced Datadog, we just kind of jumped in. And then I'm going to give a live demo on how to create and deploy a Datadog monitor using Terraform CDK. Then we'll open the floor up for questions and discussions. So I recently posted a message on Engineer All requesting for comments on our new monitoring tool Datadog. And I'm not going to go over each bullet point, but to iterate only on a few really important ones. So the first thing I want to iterate is why having and knowing a monitoring tool in general is a good idea. So applications tend to break. They tend to break a lot even after an initial perfect launch. A monitoring tool gives us the observability of the application and helps us diagnose breakage, especially as we scale. We develop applications for people to use. As an engineer, instead of relying on support to give us user feedback, we built tools to learn about the unpredictables in the production environment ourselves. It can be invaluable data to reiterate on our software and improve its quality. This also reduce devs and ops silo and encourage engineers' growth to know a little bit about everything. So this will significantly shorten response time when we have engineers armed with the knowledge to support our application in production. So next, I want to explain a little bit on why we chose Datadog as our monitoring tool for Studio and onwards. To give a bit of context, all legacy apps are currently still running on GCP telemetry. So it consists integrated monitoring, logging, and tracing. And we use Sentry for error reporting, which we don't really maintain actively due to limited engineering resource and an overwhelming amount of errors, because we send all the errors to Sentry. Studio is running on GCP infrastructure, but with Datadog as our telemetry tool. So one of the biggest advantage of Datadog is its cost. It offers a lot of out-of-the-box functionalities, over 400 built-in integrations and predefined dashboard templates at a low cost. So for reference, Google charges about 50 cents per gigabit for a month on logging ingestion alone. And I did some math, it's about $3.73 per gigabyte, while Datadog charges 10 cents per gigabyte for ingesting, processing, live tailing, and archiving all logs. Granted, Google offers default infrastructure logs free of charge and the first 7 gigabytes per project free every month, but it's still a very large price difference. Datadog can correlate the 3 pillars of observabilities. They are metrics, tracing, and logging. I may also add error tracking into one centralized platform and dashboard. So no more maintenance on multiple tools and platforms. Datadog APM, or application performance monitoring, can be configured in different dashboards based on environments, services, infrastructure hosts, etc., and ensures a expected level of service as measured by performance metrics and the user experience monitoring. An imminent and more relevant improvement for us is our logging system. If you ever come across this document, this shows a graph of our log service in the legacy app. The front end uses Angular logger. All right. These logs get aggregated by the remote logger service. As we post them on our log service endpoint, we inject the server logger Winston with a vector function and a client logger label, and pass all the browser logs to the server logger so that both browser and server logs are transported to GCP logging. As you can guess, the drawback of this, if we're using tracing, request logs are correlated with requests made on the log service post endpoint, as opposed to the actual request endpoint. But with Datadog, I don't know why it's not showing. Refresh. So with Datadog, we use this logging. We use its logging framework for browser logs. So both browser and server logs are hosted on Datadog's logging endpoint and can be correlated with its out-of-the-box tracer and real user monitoring. So it's much simpler, and we can inspect errors occurred during a request and its performance. Datadog also allows us to configure downtime and mute alerts during off-peak time, while GCP doesn't really have that option. So one of the biggest downside of Datadog is that it can easily become another layer of abstraction with added cost for something GCP already does. I'm actually going to open up the floor for this discussion later after we go over the Terraform CDK demo. So now let's jump into Terraform CDK. I will do a quick demo on how to create and deploy a Datadog Monitor. So for those who are not familiar with Terraform, Terraform is a tool that manages infrastructure as code created by HashiCorp. CDK for Terraform stands for Cloud Development Kit for Terraform. It allows developers to use familiar programming languages to define and provision infrastructure. In order to use CDK Terraform, we actually have to install the CDK Terraform command line tool globally. So go to the correct directory by running CDK TF. Actually, we're going to use, we can either use brew install CDK TF, or we can use npm install globally. But I already installed the CDK Terraform, so I'm not going to do that. One way to verify that it's installed successfully, you can just run CDK TF help. So this tells us that it's been, successfully installed. And next, we're going to create a project and initialize a project. So if you have ever looked into the Terraform CDK directory in our code base, this is where we have all the CDK Terraform projects. We have used we have used it to deploy Cloud Run backend and a GK cluster. And CDK Terraform generally can create, update, and delete resources. It depends on the resource we're managing. Sometimes it can only create. So I'm going to create a new folder. In here, we can just call that Datadog Monitor demo. So CDK Terraform can only initialize a project within an empty folder. So I have to cd into the directory. And what I run the command to initiate is going to be CDK TF init. I'm going to define the template to TypeScript and using the tag logo. That just means I'm going to save the Terraform state on the logo disk. I'm going to press enter. So just press enter again for the default name and description. So now it's installing a bunch of configuration files and no modules. All right, it's done. So let's take a look at what we have. So a bunch of new files are generated, right? Like we have this test directory and we have no modules. A couple of files like we really care about are number one, CDK.json. This is actually the CDK Terraform configuration file and where we can add the provider. So if we're creating a Datadog Monitor, we need to add the Datadog provider in here. A provider is basically just a Terraform plugin that allows us to manage external APIs. Then we have the help file that kind of lists a bunch of very useful commands. It also tells us the pre-built providers, what they are. So Google is actually one of the pre-built providers. And then we have this main.ts file. This is where we define our stack and resources. So every time you initialize a project, we always get like the main file initialized with this template, right? And it starts with the myStack class. And the scope is always kind of a default to construct. So let's see. Give me 1 second. So I just want to, I'm looking at my notes. So like the construct is a general term that we can use to describe parts of our CDK Terraform project, because every element in a CDK Terraform application is a descendant of the construct base class. So the entire application, each stack and each resource are all constructs. We can also import custom construct classes. So before we define any resources, we need to actually generate or install the Datadog provider. So when we go back to, if we go back to the configuration file, we just need to add Datadog at version number. So if you're ever in doubt what version you should put in, you can always look at the Terraform registry. It'll give you all the providers that are available. So Datadog right now has the latest version at 3.11. So I'm just gonna put that in and save it. So one thing I want to point out is that because Datadog is not a pre-built provider, it's a community provider, we have to actually provide the full qualified name. So this is if we're actually adding a Google provider, right? And I can just do Google at version blah, blah, blah. That's something kind of useful to know. So I'm gonna save this and go back to terminal. Now I'm gonna run CDK tf get. So notice I'm still in this directory, right? Like I have to run these actually within the project directory. So when I run the command, it's generating and downloading the provider classes. And it created this new folder called .gen. And when you open it, you can see that there's a lot of classes that basically related to Datadog monitoring tools, right? So there's this monitor thing class that we'll be using. And it's actually, it has the interface, so it has like the typing, it has documentation, it has like the implementation, so like it's pretty useful. Now we go back to, we go back to the main file. So this is still empty. But for the sake of time, I already predefined our stack and the resources. So I'm just gonna copy paste. And we can go over this from the top. So the two classes we really need are Datadog provider and monitor. And you can import that from the newly installed provider folder, right, from this folder. So anytime you need to interact with a cloud provider, we need to get authenticated. That's what Datadog provider is for. And in order to get authenticated, we need environment variables, secrets, right? Secrets to actually get us authenticated through Datadog. So that's what these environment variables are for. So right now, I think that the Terraform CDK, we're not really configured to use get configure store, but I think that's in the on the to-do list for the future. But right now we're just kind of these environment variables are getting values just at runtime. So the Datadog API key is what was required by this class, and the Datadog APP key is also required by this class in order to get authenticated. And I use the other environment variables like the environment region to basically for a prefix. A prefix is just like a unique ID you provided for the stack. So the stack requires 2 arguments, an app and an ID. And also these environments are kind of like defined in the file in the lib environment file. So what we do is we just read the environment from process.mv, right? And we return the value. Sorry, yeah, Katie, you have a question?
Yes, I was wondering if you could show us, so you've done all this, like where does it go? Can you show us how to get to Datadog and what we're starting to start to look at?
Yes, so I will get to that in a minute. Like I am going to deploy this to Datadog, and I will show you like where it shows from,
Okay.
you know, this.
Great.
Sorry, it's good. It's taking a little bit longer, but I just want to give you like a better, you know, like a review of this. So yeah, if you are interacting with Google, you will need a Google provider with like, you know, Google application credentials, right? Sometimes it could be a service account, sometimes it could be a personal credentials. And this right here is a resource that we will be creating on Datadog. So this is a monitor. I think in order to deep dive into the syntax of a Datadog monitor, we might need another session. But right now, you just need to know this is a monitor that will notify me to my, it will send a notification to my email whenever HTTP 404 get failure rate is higher than 50 for the last 5 minutes. So it's just a very simple monitor, like arbitrary. I just come, you know, just for like demo purposes. But these are the required arguments that you need to provide to this monitor class. If you click into the monitor, right, you will notice that there are actually a bunch of other optional arguments you can supply values to. That way we can like actually, you know, provide more details and then just fine tune the alert. If you're ever like don't understand the syntax, or you want to, you know, don't understand how do you provide these values, you can always open the documentation links in the comments. It's very useful. So to basically like open up to this page, it'll give you like example, tells you how to the schema and like what is required and what is like the usage for each property. And you know, it's all in the comments. It's very useful. Okay, so now let's see. We are going to. Oh, before I do that, I just want to make a point that if you create multiple stacks within the same main TS file, the latest stack is going to overwrite the previous one. That's just how currently CDK Terraform is designed. It's still in beta. I think it will start to support multiple stacks soon. I think they're working on that. So now we have this done, and we are going to try to deploy this. So before I deploy, I need to, right, I need to like supply all the secret values, and I have a script that I keep all the secrets in my local branch. So I am just going to enter that. You can either export the environment variables and, you know, just like let this shell remember, or you can just supply the values before you run the CDK Terraform command. So these are the 4 These are the 4 variables I need. I think Terraform environment will be testify H. And now I'm going to run CDKTF synth. So you don't really have to run this. It's just every time you deploy, it will synthesize. Synthesize just means it will convert the code into a Terraform JSON configuration file. But if you like to, take a look at the file to see what the converted code is like, you can always just synthesize it first. So this is done, and a synthesized configuration file now is generated in the folder. I think is monitoring demo, right? I think it's CDK Terraform output, and this is the file. Oh wait, let me see what happened. So did I copy paste? I don't know if I did that. Oh, I didn't save. Sorry. So I need to save. Just do it again. Because I realized that when I look at the JSON file, it has nothing. It should have the resources that we defined. For stack, it errored, did it? Let me see. Oh, so it went through. So now, so here, right, this is the generated configuration file with all the secret here and what we defined as our monitor. So next I'm going to do the deployment. You can either do deploy or apply. Yes, Katie. You're mute.
I just want to do a little time check, make sure that we have time for discussion. We want to make sure that we get through all of the topics.
Sure, sorry, it's almost done. Almost there. So yeah, we can do CDK TF apply or deploy, it's the same thing. If you are sure of where you're deploying, you can even put a tag auto approve. But I always like to see what I'm deploying. So if I enter, click enter, it's going to synthesize again, right? And oh, actually, I want to show you before. So now it says resources Datadog Monitor, and the name is Datadog Monitor demo. Difference is it's going to create one monitor, right? And you can put in yes as a value. So if you put auto approve, it's just going to go straight. But before I actually enter yes, so right now on Datadog Monitor, so if you go to the column and there's a monitor, we have nothing here. It's just like one auto clock and sync, right? But after I enter yes, so now it's created successfully, and I refresh the page, so now the monitor is there. Yeah, so that's how you actually can use CDK Terraform to create monitors and manage, SRE trees that way. It's actually really simple, really, really useful. Okay, so that's it for. Actually, one more thing. We actually have this script, GitHub CDK TF deploy. This is where the CDK Terraform deploys command is being called right here. And this script is being called by a bunch of NX project JSON in the deploy studio stage in a command. So I just want to show you that. All right, so that's it for the CDK Terraform. Now it's time for discussion and questions. I will probably skip most of the discussion topics on the ADR because you can just like kind of read in and comment either on the post or the documentation itself. But a main discussion I want to have is how do we configure Datadog at this stage in a way that we can easily manage it later on, right? So I think it's important that we configure our modern platform and dashboards to be intuitive, organized, and easy to use by all engineers from the start for a better developer experience. Both GCP and Datadog have a medium to steep learning curve already, in my opinion, and we don't want to add complexity and confusion to the mix. So we currently integrate GCP and have all data pipe into Datadog. I'm kind of sensing like a Sentry pattern where like, we just pour all the data in until it becomes too much to manage. So I think personally, I think we should do some organization and filtering on what type of data we pipe in as opposed to pipe in everything. And I've had this discussion with Ryan and Anson before, and I think they will disagree with me on this. And I understand that we need to be careful not to over-engineer too early. I also understand that we, should be focused on video engineering because the Screencastify is a video recording product, right? But without spending time on reliability engineering, it's almost impossible to engineer our product well. Therefore, I want to hear your opinions on this. And that's it from me.